Hi everybody, this is Miss McClellan here to go over IM2 Notes 8.3.2 with you. How does the area change? Today we're going to continue investigating ratios between similar figures. Oopsie. Now, as we solve today's problems, we're going to look for connections between the ratios of similar figures and what we already know about area and perimeter. We have just one learning goal. It's that you will be able to generalize to make a rule for the relationship between perimeters and areas of similar figures. Period. Okay. So we start with this problem about a team photo. It's going to be where we have to scale up a drawing and think about pricing. Okay, Alice has a 4-inch by 5-inch photo of our school's championship girls ice hockey team. To celebrate the recent victory, our principal wants Alice to enlarge her photo for a display case near the main office. So we're going to be enlarging her photo. When Alice goes to the local print shop, she has a bunch of choices. She could get the 7 by 9, the 8 by 10, or the 12 by 16. She's afraid that if she picks the wrong size, part of the photo will be cut off. So, which size should Alice pick and how come? Well, let's think. So, we've got this 4 by 5-inch photo. Let me just draw it. This is 4 inches and this is 5. And it's a picture of a bunch of people on a team. They did really, really great. Wow. And we're enlarging it, and we want to enlarge it so that none of the photo is cut off. So let's see. If we do it to 7 by 9, let's see, 7 and 9. Well, do we have a constant scale factor, or is something going to get cut off? So 4 times k is 7. K is 7 over 4. Is 7 over 4 equal to 9 over 5? I'm going to put it in my calculator. Okay, this is 1.75. And 9 divided by 5 is 0. Sorry, 9 divided by 5 is 1.8. No. So 7 by 9 doesn't work. Let's check 8 by 10. Is that going to be the same thing, just scaled bigger? Let's see. We've got 4 by 5. K is 2. This one works. So we need it to be the 8 by 10. She needs to pick the 8 by 10. She should pick the 8 by 10. It will be similar to the 4 by 5. So everything will fit perfectly. Okay, that's that. let's go do the next problem. Oops. Okay, the cost to print Alice's 4 by 5 inch photo is 45 cents. All right. Assuming the cost per square inch of the photo is constant, how much should it cost to print the enlarged photo? Well, let's think. Here I've got a 4 by 5, and I'm enlarging that to 8 by 10. This is an area of 20, and this is an area of 80. The linear scale factor is 2. But if I notice, because 2 times 4 is 8, but if I notice 20 times, because 20 times 80 has a scale factor of 4, the area scale factor is 4, which is 2 squared, period. Since the area is times 4, the bigger photo will cost $4 times 4 times 45 cents, which is, let's see, 20 cents less than $2, $1.80. This, of course, is assuming that the cost per square inch of photo is constant. So for every square inch costs the same amount. All right, let's see. Next problem. Now, surprise to Alice, the vice principal ordered an enlargement of her photo, and his cost $7.20. Can you believe that? That's so big. Okay, let's check. So we are going 4 by 8, which is 45 cents, all the way up to, I'm not sure, question mark by question mark. Going to assume that this is a good enlargement where the shapes are similar and nothing is cut off. And this costs $7.20. So the area scale factor, which I'll call k squared, is 0.45 times k squared equals $7.20. I divide both sides by 0.45. And I get k squared is, let me do that on my calculator, 720 divided by 0.45 is 16. I take the square root of both sides and I get that k is 4. So if the area scale factor is 16, this is the linear scale factor. Because 4 squared is 16, k squared. Anyway, the linear scale factor is the square root of the area scale factor. Oopsie. Ugh. So the dimensions are going to be 4 times 4 is 16. And 8 times 4 is 32. So the principal's photo is 16 by 20 inches. The VP's photo is, 16 by 20. Sorry, this was supposed to be 4 by 5. 5 times 4 is 20. 16 by 20 inches. And then I want to highlight something, just point out. To go from linear to area, you square the linear. So linear squared gives you area. And by the same token, the square root of the area is the linear scale factor. So I represented this here as the square root of k squared equals the square root of 16, and k is 4. That's just going backwards. That's starting with the area and getting the line by taking the square root instead of starting with the line and squaring it to get area. These are opposite operations. They're inverse operations, and they undo each other. Okay, next problem. IM2 8.3.2. Okay. 8-65. 8-65. So far, we've discovered and used the relationship between areas and corresponding sides between areas and corresponding side lengths of similar figures. But how are the perimeters of similar figures related? Analyze the pairs of similar shapes below. For each pair, we'll calculate the area and perimeter and complete a table like the one shown below. To help see patterns, we'll write fractions in lowest terms or calculate the corresponding decimal values. Okay, let's look at part A. What is the ratio of the sides? I'll do the perimeter first. Yeah. Here we go. So this is a rectangle. So I've got the perimeter for this one is 15 plus 15 plus 2 times 6, which is 30 plus 12, and that's 42. So the small figure has a perimeter of 42. Okay. The area of the small figure is 6 times 15, which is 2 times 3 times 15. 2 times 45 is 90. Is 90. Okay. The large figure, assuming that these are similar, which, we're told they are. So I need to find the scale factor. K times 15 equals 25. And the scale factor is K is 25 over 15. That's the same as the ratio of sides. So I'm going to write it as 25 over 15, but I'll write it as a decimal. Okay, that's 1.6 repeating. If you prefer, you could also write that as 3/5. 3/5? 5/3. Just kidding. Okay. Anyway, let's look at the perimeter of the larger figure. I need to multiply 6 by 25 over 15, or by 1.6 repeating. So times 6, I get 10. Since this is 10, the perimeter is 10 plus 10 plus 50, which is 50, 60, 70. So the perimeter of small figure is 70. The ratio of the perimeters I'm going to do the large figure divided by the small figure since that's what I did to find my scale factor, and I want to be consistent. Okay, 70 over 42. I put that in my calculator. Oh, and would you believe it? It's also 1.6. Let's find the area. Okay, the area of the larger figure is 250. That's 10 times 25. Okay, 250. I'll do the ratio of the areas again. I'm going to put the large figure on top because that's just what I did when I was doing ratio of sides. So 250 over 90. What's that equal? I'm betting you anything. I have a prediction. Is it 1.6 repeating squared? Because I think the ratio of the areas should be the square of the ratio of the perimeters. But let's check. 250 divided by 90 is 2.7 repeating. I'm going to check my prediction by taking the square root of that. Yes. It is the square of the ratio of the perimeters. And of course it is, because the ratio of the perimeters should be the same as the scale factor. And the ratio of the areas should be the same as the square of the linear scale factor. Okay, let's go. One more. Two more. So for this one, we've got ratio of sides. And I can't immediately do it because fun, I have to find these sides, but that's okay. I have a 30, 60, 90 triangle and I know how to do that. So let me draw my base triangle. That helps me. This is a 2, 1, root 3 triangle, 30 degrees here, 60 degrees here. So 4 divided by 2 gets me this side. And now I can find my ratio of sides. I'll do small over large. 2, 6. Which is 1/3, which is 0.3 repeating. Let's find the perimeters. In order to find the perimeters, I have to add everything up. So this is going to be 2 root 3. This side's 12 because it's 6 times 2. And this side is 6. Oopsie. 6 root 3. So I'm going to do this on my calculator. Okay. I add all of these up for the small one, and I get about 9.5. I add all these up for the large one, and I get about 28.4. And let's check if this ratio is, again, a third. 9.5 over 28.4 equals, would you believe it, 0.3 repeating. Golden. I bet you anything that this is going to be, what did it happen? I bet you anything that this is going to be 0.3 repeating squared. Okay, let's check though. So the area, this is a triangle. Area of a triangle is 1/2 base times height. So for the large triangle, I have 1/2 times 6 times 6 root 3, which is 3 times 6 root 3, which is 18 root 3. That's for the large triangle, 18 root 3. For the small triangle, I have 1/2 times 2 times 2 root 3, which is 2 root 3. This ratio of these areas is 2 over 18, which is the same as 1 over 9, which, would you believe it, is 0.9 repeating, and that is 0.3 repeating squared. Just kidding. I made a mistake. 1/9 is 0.1 repeating, and that is 0.3 repeating squared. Boop. Fixed it. Okay. Next problem. Now we have some trapezoids. All right, and we continue. So here for this part, we have the trapezoid, and we can already do the ratio of sides. 5 divided by 40 is, let me get my calculator, 5 divided by 40, enter, is 0.125. And in order to find the perimeter, we simply add all the sides up. So that means I need to find the scale factor. Here I would be multiplying 5 times 8 is 40. Is that right? Good. And then 13 times 8 is 80 plus 24 is 104. And then these are also 40. Let me erase this piece right here so we have one room. All right, so the perimeters are 5, 10, 15 plus 13 is 28 for the small figure. And for the large figure, it's 40 times 3, which is 120, plus 104, which is 224. Okay, now we do the ratio of the perimeters. That's 28 divided by 224. And you may have noticed the pattern, which is that, do you have a highlighter? Yeah. The ratio of the sides is always the same. I'll do it in highlight in yellow. Is always the same as the ratio of the perimeter. And so I'm going to make a prediction. I predict that this will be 0.125, but let's check. Okay, let's check this. Can I? Okay. 28 divided by, get rid of this. Delete, 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 delete. All right. 28 divided by 1. No, sorry. 28 divided by 2, 24 is 28 divided by, okay, it's the same thing. You'll have to trust me because that calculator is being a pain. This is the same as 0.125. All right. Now we need the area. The area is a little bit less obvious, but I think we can do it and it'll be fine. Okay, so here we go. We're going to find the area of this little triangle. And to do that, I notice that this distance of 13 can be split up into pieces. So I'll do it as, this is a length 5. This is length 13 minus 5, which is 8. And to make a total of 13, And considering that these two lengths should be the same, since this is an isosceles trapezoid, I know that we need 5 minus 13. Oh, sorry. This is length 5, and each of these add up to 8. So this is 4 here and 4 here. So then the question is, how tall is the trapezoid? And I'll call that x. And since this is a little right triangle here, I have that the legs squared, x squared plus 4 squared, equals 5 squared. So I have x squared plus 16 is 25, which tells me if I subtract 16 from both sides that x squared is 9, and therefore take a square root of both sides tells me that x is 3. Now the area of a trapezoid is equal to, and if you didn't remember this, you could find the area of the triangle separately and then do the rectangle here, but the area of a trapezoid is equal to 1/2 times base 1 plus base 2 times the height. So for a small trapezoid, that's 1/2 times 5 plus 13, which is 18, times the height, which is 3. And this becomes 27. So the area of my small trapezoid is 27. All right, I'm going to write that down. Now let's find the area of my larger trapezoid. Okie dokie. And I'm actually going to do this in a roundabout way. Now, I know that the linear scale factor is 0.125. And I know that the area scale factor is going to be the linear scale factor squared. So I know that the area of the ratios is going to be 0.125 squared, which is, let's see if this will work this time, 0.125 times 0.125, enter. Delete, times 0.125, enter. How annoying. 0.125 squared. How annoying. What if I look up a calculator? 0.125 times 0.125 equals 0.015625. 0.015625. 0.015625. Okay, and that tells me that if I multiply that number by 27, I should get the area of the larger figure. So I'm multiplying this by 27, and I get, oh, sorry, I should divide 27 by that number. 27 divided by 0.015625. 1728. Okay, so the last thing we're going to do in today's notes is summarize our findings. So to summarize our findings, the question is, how are the perimeters of similar figures related? And this is just straight notes. We're just going to write the answer down. Okay. The area scale factor blank is the linear scale factor k squared. So if you have the linear factor, you can get the area scale factor by squaring it. If you have the linear scale factor, you can get the area scale factor by squaring it. Period. Similarly, if you have the area scale factor, you can get the linear scale factor by taking the square root. Period. And then we close with one example. We make a table, linear scale factor, area scale factor. The linear scale factor is k. What is the area scale factor? If the area scale factor is, I don't know, how about the letter p? What is the linear scale factor? If the linear scale factor is 5, what is the area scale factor? If the area scale factor is 36, what is the linear scale factor? If the linear scale factor is 2.7, what is the area scale factor? And if the area scale factor is, I don't know, I'm just making up numbers, 4.2, what is the linear scale factor? Notice I don't have any negative numbers because we are not discussing negative area. Okay, so if the linear scale factor is k, then the area scale factor is k squared. If the area scale factor is p, then the linear scale factor is the square root of p. If the linear scale factor is 5, then the area scale factor is 25, because 5 squared is 25. To get from the area scale factor of 36 to the linear scale factor, well, I simply take the square root of 36, which is 6. If the linear scale factor is 2.7 and I want to get the area scale factor, well, I take 2.7 and I square it. I'm going to do that right now. 2.7 times 2.7, 7.29. And if I have 4.2 as my area scale factor, and I want to get the linear scale factor, well, I take that square root of 4.2. Put that in a calculator. Square root of 4.2. And I get 2.049. Okay, everybody, I hope you have a great day. You don't have to do the problems on the following page. I do hope you do your homework, and I'll see you next time. Bye.